So in this lecture, we will look at dealing with different types of media and finding out information on the media, which would include your hard drive, how to format the media, how to find out information, very detailed and specific information on media, how to find out how much disk-free space that you have under your Linux box, how to manually mount a USB flash drive. I used to have to do this manually all the time. Now the Linux distributions are really good about auto mounting, but sometimes it just doesn't work. So you got to be able to both mount it and unmount it. And all that simply means is making sure that your operating system can read and write to your thumb drive or whatever type of media you're using. So let's get started with that. So a student suggested, or he told me what he did, and I think this will be helpful to other students, and that is he would open two terminals. So you can open up another terminal right below here. You can fit this in the window. It's a little small on the screen. But now you have two terminals running, and in one you can run the man page for a command, and the other you can actually type the commands. And so this was a brilliant suggestion. So I suggest that you do this so then you can just scroll up and down, and I'm doing this with my mouse on a Mac. Scroll up and down, or just use your keyboard. That's the J key, that's the K key, to scroll up and down and try some of these commands. So the first command we're going to run is just to find out a little bit more about our Linux system. It doesn't have to be run as root. So it's called uname, and what that does is prints the system information. So uname, let's do that --a, Linux Mint 12, and a generic install of a kernel Ubuntu symmetric multiprocessing, and when it was installed, and for the type of architecture, x86 64-bit GNU Linux installed. So the A gives you all the information. If you scroll down, you can see you can give specific information just by using one of these other flags. So that might be important for troubleshooting or determining what is the latest kernel that you're running. Okay, so our next command we're going to look at is to see what is mounted on the system. Now, what does mount mean? Mount simply means that in order for the operating system to read the table of contents, let's say, of your file system, that it needs to be mounted in memory. And we know that in Linux that everything is a file, and we can treat it as a file. And I believe we've discussed before that that any devices that are attached to your system are mounted and can be we can find information on them by looking in the dev directory. Let's do ls-al dev, and we'll pipe that to less to see all the different device files in here. Notice that there's loop files, and that's for the loopback device ports. And if we go on down, notice we have some for RAM. Here's SDA, SDA1. We'll look at that more closely in a second. And you notice that we have the TTY0, 1, 2, and so on. We keep going down. And as we talked about in a previous lecture, is that these TTYs are the terminals that we can log into. Not a pseudo terminal like we would when we're SSHing into another box, but actual terminals on here. And so let's type, we're just going to type mount without sudo and see what we get. Okay, this gives us a lot of information. I'm not going to go through, some of this gets a little more technical, but I will go through the parts of the output that are relevant to what we're discussing. But notice here we have a dev SDA1 that's mounted on root, the root directory. Type ext4. What does all this mean? So before we go and answer these questions, but it does show you what's mounted. So dev SDA1, it turns out that that's important, and because that is part of your hard drive. So since we're out of this, let's clear. I'll first ask this. Let's run sudo fdisk. Sorry, let's go up here, click Q to get out of here, and type man fdisk. It's a partition table manipulator for Linux, but also it can provide you with information on the partitions of your devices. So if we scroll down a bit, and what I wanted to get to was the L, the -L, list the partition tables for the specified devices, then exit. And since you're this far into your degree, you should have already taken a course that looked at partitions, but you know that you can have multiple partitions or sections on your hard drive, and that's why you can have for a single hard drive, you can have, let's say if we're looking at it in terms of DOS and Windows, you can have a drive C, D, E, F, and so on a single hard drive. Those are different partitions, and they're treated distinctly. So can you have the same thing in Linux? Yes, you can. And here this shows you. And remember, this is the virtual drive, but you can treat it for what it's worth as a physical hard drive. But you see that the dev SDA is about 9 gigabytes, and it tells you the number of virtual heads, sectors, and cylinders, the total number of sectors, and the sector size. And sectors are physical hardware units. That's the smallest addressable space on a hard drive. It's a physical unit, and typically, not to get too technical, but usually file systems address a file as a multiple of number of sectors. So you can have anywhere from one sector equal to something called a block or a cluster, which is the smallest addressable space for a file, up to, let's say, 64 sectors, depending upon the file system. Now, if we look down here at the bottom, we see we have the columns device boot, start, and end. These are the sectors. The number of blocks, which is I just was saying that a block is a multiple number of sectors from 1 to 64. And so dev SDA1, so the S stands for SCSI, the A stands for the first SCSI drive, and the 1 in here stands for the first partition. You notice that it has 3 other partitions. The first one has an asterisk in the boot column, which means that this is what is read as your boot drive. SDA2 is an extended drive, and the reason this was created, notice that it goes from 1 to 2 to 5. On a typical IDE drive, you can have a maximum of 4 different partitions. And so anything over 4, let's say you wanted 10 different partitions, you have a very large hard drive, is that you're going to have to create something called an extended partition as a container. And then within that container, you can then put as many, I think up to 64 partitions under that extended container, the extended partition. So, and that's what this is. This SDA5 is held within SDA2. You notice that it is a swap file. And so you should all know what a swap file is. It's essentially virtual memory. So this holds our file system, all our files, and we have an extended partition, which is a container which holds our single swap file. Okay, so now if we go back, if we arrow on up and go back to mount, we see that dev SDA1 is mounted on the root file system. So it looks like that we have to take our device and actually mount it on a directory with a type of file system. And one of the modern file systems for Linux, the newest one is ext4. There are very many other Linux-based file systems, but that is one of the more common ones. It's a journaling file system. And just a couple of things in here. Let me point out this one thing. Notice this says RW, that says read write. So when you mount it, you can allow the reading and the writing to SDA1, which is mounted on root, on the root directory. And so, well, you say, well, why wasn't where's SDA2 and SDA5? Those really don't get mounted. And that is just for the purpose of the operating system and file system to write out information, the virtual memory, things that need to be swapped out to a Linux swap file. And so those can't really be directly addressed by the user, only the operating system. So that's why it's not mounted. But you could have SDA1, SDA2, SDA3 mounted on different different directories. For example, oftentimes home, boy, there's a lot of users on this system. Home will be on its own partition, and sometimes var will be in its own partition. And you can do that yourself. You can set all this up when you're installing Linux so that you do have separate partitions for, or even separate hard drives for the different directories under your Linux system. So let me do one thing. What I'm going to do is I'm going to plug in my USB drive here. It's a small one, and I keep a small one around so that I can write over it and format it and do whatever I want to it. And some of the things I'm going to be doing to it are destructive. So if you have an old USB thumb drive you don't use or you don't mind overriding, you can follow along with what I'm doing. Although remember, this is destructive and it will write over the files. And so I plugged in my USB thumb drive. Now I'm running this under a Mac, so this is what it's going to give me. So I can connect to my Mac or I can connect to Linux. So I'm going to connect to my Linux, and look what shows up. This is our little file explorer here, and it shows that we've got 3 files on here. So what does that mean? Let's go out, let's clear this, and let's go back and let's run sudo fdisk-l. Well, look, if we scroll back up, that's the same information we saw previously for SDA1, but if we scroll down, notice now we have an SDB. And so B, meaning it's the second device on here, and it tells us how large it is, 16 megabytes. Notice that it has a single partition, SDB1. And it shows you the starting and ending sectors, the number of blocks, and what type of file system it is. And we're not going to go too in-depth into file systems. You'll learn a lot more about that when you take one of the forensics courses. So if we go back to mount, what do you think is what we're going to see? All the same information up here, but if you go to the bottom and look here, dev SDB1 is mounted on media CB6D5035. Type VFAT. You saw up here it was a FAT12 system. VFAT is just a virtual FAT file system which allows for long file names. So, and notice also in here this is mounted read-write. So if we want to see the contents from the terminal of this, where do we go? Do we go here to the media folder directory, or do we go here? Well, the mount point is here. So if we type CD and media and CB and hit tab, there are files. Notice also that there's a hidden directory, trashes, and a hidden file here. Okay, so we'll go back up to our home directory. And now I want to, how do you eject that disk? How do you eject it if you're running a version of Linux server and you don't have this nice little GUI that I showed you previously that would allow you to do that? How do you unmount this right here? Well, it's very easy to do, and what you use something called the umount command. Notice it doesn't say unmount, it says umount. and then we can give it media and the directory where it's mounted. We hit enter. Notice that if we type mount again, it's not there, so it's no longer mounted. But wait a second, I didn't take my disk out of the USB receptacle. Okay, well, let's go back here. There it is. So it's still inserted in the system, it's just not mounted, which means we can't read and write to it. It needs to be mounted in order to be read and written to. Well, how do we do that? How do we set it up? What if it doesn't automatically mount? Trust me, that can be the case. You may unplug a thumb drive in, or a external CD or DVD drive, or an external hard drive, and you can't read or write to it. So what do you do? Well, let's just see something right here. Let's make a directory. Call my mount. My mount, there's nothing in it. Let's manually mount that thumb drive. We do that with, guess what? What command? The mount command. So sudo mount. Sorry, I keep forgetting. Mount. And the mount command is used to mount a file system or show you what is mounted. This -T here, usually you need that. And so here's the standard form of the mount command. Mount-T, the type of file system, and I'll make it easy for you. The device, what was the device? Remember dev sdb1? Yes, and the directory where you want to mount it. Boy, it sounds simple, doesn't it? So sudo mount-T. What kind of file system was it? I said it was a FAT12. I said it was a vFAT, right? Let's just force the mount command to read the master boot record, which is the first 512 bytes of the file, to see if it can determine what type of file it is. And then we type the device, dev sdb1, and then my mount. That's where I want to mount it. I don't know if you can see right here. Let me move this up a little bit. Just see that? See this right here? It mounted it. Okay, did it really? Well, I can tell from there it did. Let's type mount. At the bottom, dev sdb1 on home PC my mount, type vFAT. It read what kind of file system it is and read write. Now let's say we don't want that mounted anymore, so what do we type? Sudo umount what? Home. Oh, first of all, let's do this. cd home PC my mount. Okay, there's the stuff. Okay, so let's sudo umount home PC my mount. What's going to happen? So that's the correct format for the command, right? Oh, the device is busy. Well, sure. Look where we are. We're in the directory. We don't want that. Let's get out of the directory. So we're back in our home directory. Let's arrow up. And now let's unmount it. Notice I said it's typed umount, but I'm unmounting. Oops, let's type mount, and it's no longer mounted. Okay, so what I want to do is I want to repartition and reformat that drive. How do we do that? Okay, so we know it's only got a single partition. Tell you what, let's just leave it as the single partition. So it's been partitioned. What we want to do is we want to reformat it. How often do you need to reformat a hard drive? Well, sometimes you do. You may want to reformat a flash drive. You can do that. So how do we do that? Well, as it turns out, there's a command called mkfs. Make file system. Build a Linux file system, but you can actually build other types of file systems. So the J key to go down. So the -T is the file system type, specifies the type of file system. The default is ext2, which is a rather old Linux file system that does not do journaling, so it's not as reliable as ext3 or 4. And file system options, and we're going to make it easy here, but you see at the bottom, see also mk-dos-fs, mke2fs. What this is showing you is that these are the commands that kind of put together the dash T up here, so that if you want, let's say, a VFAT drive formatted, you would type mkfs-vfat. If you wanted the XFS file system, you'd use this. If you wanted a Minix, you would use this, ext4 this. So let's format. It was formatted VFAT before, so I'll tell you what, we're going to format it a couple of times. Now, what's going to happen to those files on there? Well, once you format the drive, essentially what it does is that if it does, well, at least in Windows, you know, when you do a quick format, what that does is it writes over the table of contents so that you can start from afresh on your hard drive. So it's like wiping out the table of contents. In a book, if you took a book and you tore out the pages, what happens to all those chapters after that? Guess what? They're still there, but it's a lot harder to find what you need. The same thing when you do a quick format in Windows, is that it writes over the table of contents of the hard drive. A full format, on the other hand, writes over any and every bit, and so that would be analogous to setting the book on fire. So you can't recover anything. So if you quick format something, there is a way forensically using data recovery methods to gain back those files, but it's tedious and expensive. But it's something you'll learn in our forensics courses, so think about that. So we want to, you think make a file system requires root privileges? You bet it does. So mkfs, and we're gonna use a different file system, ext2, for the flash drive. And now we need the device. So that was dev sdb1, correct? Because we want the partition to be formatted. We hit enter. Okay, so it gives us a lot of information in here. And notice it says something about blocks, and we know what those are. See these inodes? Inodes are information about the individual blocks on the system, and that's really how a operating system file system address files, is by their inode number, not their real name, but their number. Okay, so let's mount that now. Let's see what happens. Let's see if we can just arrow back up. Oh, I ran that here. So let's clear this. And let's go back up. We'll be lazy. There we go. We're going to run the same command. What do you think will happen? Let's see if this works. Boy, I hope it does. Okay. See this? Oops. Here we go. Let's type mount. Dev SDB1 is on home PC my mount type ext2 read write. So let's go to my mount, and you see there's a single directory called lost and found, which is automatically created when it's formatted, and those files aren't on there. But can we copy some files on there? Well, let's see. First of all, let's see who owns that, because my mount is owned by root. So in this instance, we're going to have to use sudo to copy some files. Let's copy, it's got to be something small because that's not a very big hard drive. Here's a 2.dd and a winpcap. So let's copy those files there. You copy whatever files you have on your system there. That's for another class. And so we copy them to my mount. Go to my mount. There they are. And let's just click on the GUI down here. There they are. Okay, so that shows you how to mount and unmount a device, where to find the information on the type of drive, and so that was fairly easy, and also how to make a file system, and you know what kind of file systems you can make under Linux. Let's go back here and let's clear this out. Okay, I don't know how much of the file system I'm using. You know, it's easy to do in Windows because it has graphical tools. We'll do SDB. Doesn't tell me anything. How many files do I have on here? It just tells me what is the size of it. So if you type du, let's go to man, du, estimate file system space usage. And a lot of these you don't need, except maybe the -C for grand total. And you can look down and see that there's quite a few. Let's just type du-C first, and it tells you within this directory all the files and the file sizes in here, and also it gives you a total. Okay, so that tells you the disk usage for that directory, but I want to see how much disk space I have free. So if we go to man df for report file system disk space usage, it's going to tell you how much free space you have on your system. Notice the -H here for human readable, so it tells you 1K, 234 megabytes, 2 gigabytes, and so on. And so you can run all these and you can see what they do. And usually very quickly what I do is du-H. And so rather than, and it tells you the summary right here. And this is what I was looking for, the df-total. So what do we have here? It tells us the file system, the number of 1K blocks, the amount used, and the amount available. So on SDA1, I've used 68%, and that's mounted on root. Notice there's some other directories in here as well. And we get down to SDB1, and you notice that we've used 14% of those two files. In total, we've used 24% of our space. So that's a nice overview of dealing with your media, how to get information on your file system and your media. And I suggest you try these. You know, if you do have an old thumb drive, you can format it in all the different types of formats, see what works and see what doesn't. The reason that there's many different file systems is that as the media grew and that the designers wanted the file system to be more reliable, as they added certain capabilities to them, which you really can't work with on smaller devices. So depending upon how large your media is, will determine what types of file systems you can use. But the best way to learn about this is to try it out and see if it works.